Hi, welcome to another video on my Raspberry Pi with pulse width modulation. Last time I tried to get the pin mode instruction out of the while loop and put it here. While it makes no sense to keep assigning or setting the pin mode 1 to PWM output. Result, however, was last time that pulse width modulation didn't seem to work. I'm not happy with that, and therefore I want to try it again, because in examples that I found, indeed it is assigned once, and after the wiring PI setup, of course, then it works. So I am going to try it once again. And to do that, of course, I say here delete, and I paste again, but I need to do it like this, which I did before, but before I save and compile it, I will try the version where this is still here again and see what the result is, and I'll just give a value, and I'll do this off camera for now. And that gives a value of about changing between 3 kHz and 40 Hz. So that is not really a value that you can call consistent. And that is something I don't understand either. Am I taking the right pin? Yes, I am. So this is not consistent at all. When I take the value 1, what is the result then? The result is about the same, 4 kHz, which is, by the way, a little bit more consistent than 1024. So I'm ending this, and I will save this version, compile, and run again at 1024, and the off-screen measuring gives me 4 kHz. I change the value to 512, measuring again, and it goes off the scale, going to 1, and the value goes to 412, 4 kHz. But the strange thing is that the values keep changing, so I don't like that. But apparently for now it seems to work. Last time I also did some rewiring, and maybe that has to do something with it. Anyway, this seems to work, fortunately. I also put out the sleep of 1 second. I'm not sure if I should do that again, but anyway, this is a first try and it is successful. What I've done last time as well is checking a number of values and then measuring the frequency. For that I hold the probe against the PWM pin and read the value, and because of the fast changing numbers behind the decimal, I'm just reading the first, and that shows that 6 is in the 4 kHz range. Then 1 is the same, and that surprises me, because when I did it from 4 to 1 it did change. So now it shows an inconsistency in behavior. And I don't like inconsistencies. Now it says 4 and 1 interchangeably, so I change to 4 again, and it stays 4, and I go to 3, and the amazing thing is that when I started at 5 it gave 7 kHz, 4 changed to 3 to 6 kHz, then changing to 3 it gave 5 kHz, so it came down, and now it is at 3 again, so I would expect 5 kHz, but it doesn't do so. Now it does for some reason, and back to 4.9, so 4 I would expect 6 kHz, but it doesn't do so, and 5 I would expect 7 again, but once again it doesn't do so. Let's go to 6, and it stays at 4, so I am rather puzzled about its behavior right now and wondering if I have the right if I have the correct wire anyway. That should be this one. Yes, I have the correct wire. Nothing is more irritating as doing a measurement and having the wrong wire. But anyway, 6 gives also 4.8, so this doesn't make sense. Is it once again what I suspected earlier, my multimeter, or is it something else? Because last time I also checked the code, and despite the complete description about how to alter the code, so in order to how to alter the frequency, I didn't manage to get that, because I want to get lower than 220 Hertz, and according to the text about the code, I should be able to get 100 Hertz, but I haven't been able to manage that yet. So that is very surprising. So somewhere here I should get 100 Hertz, or am I just choosing the wrong electronics? I figure I am using the wrong electronics. So that is what I'm going to figure out right now. I already did that, I remember, but That is my focus right now, because if they say it can be done, I should be able to. So let's quit this for now and focus on exactly getting 100 Hz. One of the strange things in this whole pulse width modulation thing on the Raspberry Pi is that with wiring PI, the maximum frequency would be with 100 microseconds, giving 5 kilohertz, 5000 hertz. However, as I mentioned before, using for example setting 5, and I'm measuring on the pulse width modulation, it says once again 7 kilohertz, 7.17 or so, anyway, in kilohertz scaling. That is beyond the maximum of 5 kilohertz. Another thing is that it says, okay, apart from the 5 kilohertz you get a minimum of 100 hertz. I haven't found it yet. Studying the various instructions, trying out like wiring PI setup, and there are others like GPIO. If I use wiring PI setup GPIO, then I only have to use 12. Now I am using wiring PI 1, like I state here, which is officially GPIO 18, which is physically pin 12, and with GPIO here I can use 12 instead of 1, and that's the only difference. If they use wiring PMW output or PM write, let me put it this way, using PMW write, PWM write, yes, then I get some value. So when I am going to from 0 to 1024, you might expect somehow to get a variation between 100 Hz on one side and the 5 kHz on the other side. And as you may have noticed by now, that is not what I get. Is it on my side with electronics? Well, in the examples they use a blinking LED, and then they write just a value which indicates the brightness of an LED with, like I have shown before, a resistor of 330 ohms. Now the 330 ohm value you may change into other values, and that may or may not change the brightness. However, with all this trying out, I'm not one step closer to get the actual indicated 100 Hertz and 5 volts from the RPI, Raspberry Pi, to get the motor running as I like. So is this a dead end? I don't think so, but I haven't found what I'm looking for, which is how this software is going to work in my advantage. How do I get it to work? So far it only works for me with regulating the voltage, and previously I have clearly shown you that the pulse modulation power supply connected to the motor that I'm using is a constant 9 volts with pulse width modulation from 40 Hz to 120 Hz. So I'm really riddled. How to go on? Not quite sure, but I'm not inclined to give up. So with all the thoughts about the frequencies and pulse width, the question is, how can I solve all this while not getting the correct bandwidth frequencies? One thing that the examples don't have is this sleep. Not that I expect that removing that sleep will change anything, but I can at least try something. So right now I will compile again, and this is a comment. So it's now removing the 1 second, and let's try again. 1024, measuring again, and it says 3.8 to 4.8, 4.5 kilohertz, which really doesn't make sense if you consider that it is either 100 or 5 kilohertz. Well, this is nearly 5 kilohertz, so if I go to 1, it says exactly the same, even over 5 kilohertz now. Go towards the middle, and it goes beyond scale, and when I put it the multimeter to 200 kilohertz, it says it's 110 kilohertz, so that is beyond belief, so to say. So this doesn't work. And the big question, of course, then is going to 1 again. It's again 4.8 to 5 kilohertz. So somewhere, and I really suspect by now the electronics. How come that the electronics don't do their job? What I already did in the past is a very small circuit, putting the electronics next to it. So once again I put the pulse width modulation into the very small circuit with 4 resistors, and that should give a small glimpse. But when I look at it, it doesn't do a thing. So where do I go wrong? Where does it go wrong? I start again, and this time I start at 1. And it doesn't show a thing. And that is weird, because in the past this worked. Let me go to 512, because with that, and now it does work. That's weird. 1024, it should work as well, and yes, it goes brighter. So for some reason this does it does not work for a motor or measuring frequency, but it does work whenever I put an LED with resistors on it. And that's what I don't get. How does this work the other way and not my way? Let me put it on a very low frequency. Yeah, then you don't see anything. Hardly anything. 512, you see it working. And I'll show you on camera once again as a reminder of what worked. Alright, so far I have been measuring here with this wire right here, and it showed nothing that I could make any sense of. Now you can see this LED burning not as bright as possible. But this is a value of 512, and it has 4 resistors. So now I am changing the value to 1024, and you see it burning nice and brightly. Changing it to 10, it looks like it's off, and with the value of 1 it is next to nothing. Going to 1000, and you see it lighting up. What I don't like about this is that this does not show any value. So let me check again. 512, nothing. And this should really indicate a value. Yes, it does. It says 6 point whatever. And this is, as I already said, that is quite strange considering the fact that it is given on the website for 5 kHz to be the max. And 6 is definitely over 5. So I am giving 1024 again. It's down to 5 something, and the LED is burning bright as ever. Going to, what shall we do, 800, and it says out of range. 700 is out of range, but the LED burns nicely. I'm going to 400, still out of range. 200. Uh, 50, and it is still out of range, but the LED has gone dim. Going to 900, it burns nicely, but it's out of range. So is it even possible with this software, with this library, because that is what it is, RaspberryPi is a library, pulse width modulation library, to get this motor working in the circuit. I admit that 5 volts that is coming from this wire is not the same as 9 volts as required by the standards that fischertechnik says. It's a 9 volts motor, but on the other hand, using 5 volts it does work. 5 volts regulation does work, not pulse width modulation works. Well, here it proves the opposite with this LED. So this leaves questions all over, and I have to find out more to give a nice idea about how this whole circuit works. Does it or doesn't it with pulse width modulation the way I use it? Maybe there's still another way of getting it to work except with RaspberryPi. So this is a live demonstration, and let's get further. I did some new research, and that resulted in nice discovery that there is indeed pulse width modulation difference. The pulse width modulation that I have used so far, and then I'm referring to RaspberryPi, is actually soft pulse width modulation, and the information I found indicates that that is indeed very adequate and nice for burning an LED with a resistor, etc. However, if you want to do something other, such as driving a motor, you need hard PWM, hard pulse width modulation, and for that there is indeed a library, but that is using Python, and right now this code is very clearly C++. So what I am going to do is next time see if I can get with that library pulse width modulation running with a motor, and see how that works out. If that is the solution, I'll be happy. Will that drive both motor and LED? I have no idea yet, but it seems it won't. So for now I will change from C++ to Python, as I've done in the past as well. I've used both, doing the same, and this will also doing the same, but then in Python. So we'll see how that ends up. For now, thank you for watching and being patient on my experiments. Experiments will continue. If you like my videos, please consider supporting by allowing advertisement in between the video segments. If you don't like to watch advertisements, then please visit my website to find a way of support via PayPal. And if you haven't subscribed yet to my videos, please subscribe to my channel for more and other videos. Thank you for watching again, and bye bye.